Stanford University.
So welcome to lecture number 2 of CS 193P. We had a fantastic turnout, so welcome everybody here and everybody online. We had 32,000 downloads of the video, so huge audience outside of this classroom. So, but of course, this is the reason we're here: iPhone app development. Let's get into some of the announcements for the week. So the first thing is that the enrollment process is complete. We have sent out emails to those that have signed up, whether you got in or not. Apologies to those who didn't, but there's just not enough space. And there's always opportunities next year. If you're not sure of your status, so if you did not receive an email that indicated whether or not you made it in, please email cs193p at cs.stanford.edu, and we will get back to you with what's going on. And if you tried to enroll but you didn't make it in, please drop the class in access. We need you to do that for administrative reasons. So next thing is office hours. Okay, 2 TAs, Troy Brandt, Paul Salzman. You met them both last week. Troy Brandt is going to run office hours on Tuesday from 12 to 2 p.m. Every Tuesday on the 4th floor of Gates, room 463. And Paul is going to be running his on Mondays. Now, because we're already on a Monday, 12 to 2 is too late for this week. If you have assignment questions that you want to ask about 1A and 1B, which are this week's assignments, he's setting up a one-time only bonus assignment session, office hours, this week on Wednesday from 12 to 2 in Gates 24A. So please write this down. These will be online as well, and you can get to that information. So next thing I want to talk about is something that Apple runs every year at WWDC, which is called the Apple Design Awards. And what Apple does is they give out awards to people with the best app ideas. Visual style is always valuable. There's all kinds of, well, there's 2 different categories. There's one for iPhone development. There's one for Leopard development. Of course, this class is iPhone development, so we would highly encourage you to develop for that, especially that's what your final assignment's going to be. But you're also learning the fundamentals of Leopard development, so I would encourage you, if you have any great ideas in either category, to enter. Particularly if you want to enter your final project from this course, that's highly encouraged as well. So winners get plenty of Apple swag, including 15-inch MacBook Pro, fully stocked, by the way, 30-inch cinema display, 16 gig iPhone 3G, and a 16 gig iPod Touch, and an ADC 2009 student membership, and your ticket for this year will be paid for, will be refunded. So enter, win. I think good creative ideas have a good chance of winning. Yes?
When do we have to submit by?
That's a good question. I would say, well, WWDC, what are the dates? Okay, so sometime in June, second week or third week of June. I would guess that the submissions are a few weeks before that. If you go to the Apple developer site, there's going to be plenty of information about WWDC. Check it out there. You'll find out more information about getting a ticket and find out more information about entering. Yeah.
May 4th.
May 4th?
Yeah.
Okay, so it's a few weeks before. May 4th is the submission deadline for the design awards. So you get a month. And then for more information, here's the website. All right, so the next thing I want to talk about is the iPhone SDK. In order for you to start developing, everybody has a Mac, right? Everybody has access to a Mac. I see a lot of silver lids open right now. Of course, you need to get the iPhone SDK if you're going to do any development. It has all the Xcode tools, interface builder, all the headers and frameworks. In order to get that, if you received an enrollment email, you'll also have received an invitation to join the university program's developer program. So go to the invitation, accept it, request a certificate. A certificate is basically your individual's an individual key in order to be able to build applications. So request a certificate, we'll approve it as soon as we can, and then download and install the SDK. All that is linked there. If you did not receive an invitation, again, please email us, cs193p at stanford.edu, and we will get to you. And the next thing is we're going to need your device IDs. So UDID, every device, the iPods and the iPhones, are each uniquely identified. So that if you want to do development on the device, it needs to be registered with Apple as a developer. So we're going to figure out a system for that. We'll probably set up a spreadsheet online where you can enter that, and then we'll send you the keys that you need, and then you can start building for a device. So the sooner we get that done, the sooner you get your keys to start developing on the phones, and then fun ensues. Now the last thing here is that auditors, unfortunately, we were not able to get you into this program. So if you're auditing this course and you want to do iPhone development, you're going to have to go sign up independently. It's free to do simulator development. You go on the developer.apple.com site, you fill out the form, and you get access to the SDK. Now the SDK lets you run the simulator. It gives you all the help that you need. But if you want to do on-device development, there's a $99 fee, and then you get access to the builds for the device, and it allows you to do the same. Are there any questions about this? About any of this administrative stuff? Yeah?
When does the $99 account expire? So the student accounts expire at the end of the quarter.
Right. So these are good for a year. If you're actually enrolled in the course, again, if you're already a part of this, great. If you're not, wait till your 3 months is done. Wait till the quarter's done, then sign up. If you're auditing, you might want to go do it right now. It's pretty quick, and you get approved. And yeah. Okay. So the fun part for you guys and the fun part for us is assignments. The assignment schedule is that we are going to hand out assignments on Wednesdays. You got 1A and 1B last week. I hope everybody got 1A and 1B last week. It's on the class website. And it's due the following Thursday, 1 week and a day later at 11:59 p.m. If you get it in at midnight, it's too late. We're taking a day off. We all stay up that late because we're all night owls. So get it in. And then this week, of course, it's been a week, so you're running out of time. And to submit your assignments, most of you should be familiar with this if you've taken CS classes before. But if you go to the class website, you will see a submissions tab right up at the top. And that submissions tab, it gives you some instructions. It says you have to connect to Leland and package something and this and that. And it's pretty detailed. But follow the instructions. We'll get you all set up. And we can start marking. Now, if anybody's done early, every year we have this problem where, I don't know, there's something wrong with the scripts, or we just want to make sure that it works. So if anybody's done even assignment 1A early, please submit. I'll give you some free candy next week. But we just want to make sure this runs smoothly for when everybody tries at 11:58 on Thursday. So, okay, so now let's start getting into some Xcode stuff. So in Xcode, actually in every application on the Mac, there's a help menu. And the help menu is useful for all kinds of documentation, particularly how to use the program, how to get to different APIs. I would encourage you to use it. I use this religiously. It never gets old, and you'll never outgrow it. But if you go to the help menu in Xcode, the assignment will walk you through it. Take a look. The piece I use the most is what's under documentation. And documentation is all the headers for all the different objects. There's class diagrams. There's all kinds of great information for if you want to explore on your own. And I would encourage you to go there. And today what we're going to talk about is, questions from Tuesday. If anybody started on these. Wednesday. We'll talk about object-oriented programming. So a lot of you should have experience with this already. But some basic fundamentals about object-oriented. We'll talk about the Objective-C language, and then we'll get into common foundation classes. And foundation classes are the different kinds of structures and classes that you'll use throughout Cocoa for doing all your development. So, let's start with questions. Has anybody started with the assignments yet? Does anybody have any questions on them? Nobody started on the assignments yet? All right. Yeah. You done? All right. Any problems? Gotchas? No? Okay. So let's move on. Let's talk about basics, object-oriented basics. So OOP vocabulary. Can anybody tell me about a class? What's a class? Anybody? Yes. It's a thing, okay. It's a thing for what? What does that thing describe? Yeah, that's right. It defines. It's like a blueprint, right? So a class it defines the kinds of variables that are inside it, the kinds of data that it holds, and the different kinds of methods that you can call it, the different kinds of actions that you can perform on that class. An instance. Well, what's the difference between an instance and a class? Can somebody tell me what's an instance? I'm looking in this general direction. What's an instance? Yeah.
Well, if a class is a blueprint, then the instance is the house.
Very good. Very good analogy. So the instance is the house if the class is the blueprint. So the instance is the allocation of a class. It's the data that's, it's the memory that was allocated and the representation of that object. A method is a function. So in C++ or C, you know it as a function. In Objective-C, it's called a method. And an instance variable, or an IVAR, we call it, is basically the different pieces of data inside of that class and that are actually stored inside that object, the instance of the object. So can somebody give me an example of an instance variable? Sure.
Ford.
Sorry?
Ford.
Ford?
Yeah, it's an instance variable of types of cars.
Okay. So Ford would be actually, to take your example, if you had a class of type car, the instance variable would be type. Okay? And so Ford would be the value. But instance variable is how do I describe it? The actual data storage. So let's say type is an integer from 0 through 5, and the different types are Ford, Nissan, Chrysler, Mazda, etc. The value is Ford, and the type is the instance variable, or the storage is the instance variable. Okay, let's move on. Object-oriented vocabulary. So encapsulation. The idea of encapsulation is that you want to keep some data private inside of a class, inside of an object. So again, can somebody give me an example of encapsulation inside of an object? I'll give you an example of an encapsulation inside of an object. Let's say you have an array, okay? Now, in C, you know an array as contiguous blocks of data that each one is the same size. Well, in an object-oriented world, you don't know what that data, how that data is actually structured. So encapsulation in an array makes sure that the people using the object, the classes that use the array, don't know how that data is actually stored. It's up to the array to store that data in whichever way is most efficient for it. So encapsulation is basically that hiding, making sure that what's inside the array is not visible. Polymorphism it says different objects take the same interface. You'll see this a lot in different types. I don't know if I have a slide on this later. Different types of structures in Objective-C. For example, if I have an array and I say add object, that add object method is the same structure that the NSSet has. I don't want to get into details, but basically, the idea is that you have different. The methods each have the same structure across different objects. So that commonality. And then inheritance is the ability for one object to inherit from a parent. So if you have a class of bird, okay, birds all share some common elements. They have a beak, they have 2 legs, they can fly usually. So if you then had a pigeon, which I see a lot, I live in the city. There's, they crap a lot. So there's, that's one, that pigeon inherits from the bird. Sorry, that's what I come across. So the pigeon, the pigeon inherits from bird, and it has its own behavior. So that's the inheritance. Okay, so here's an example of inheritance, not in the bird world, but in the Objective-C world. where up at the top is NSObject. Now, in Objective-C, everything is an object. I mean, that's a generalization, but pretty much everything you're going to use is an object, and it all inherits from NSObject. And NSObject is, it takes care of all the memory management. It takes care of something called introspection. And it handles a lot of things that the subclasses don't need to know about in order for them to manage their own behavior. Another, UI control is a iPhone class for doing different kinds of action-based UI. So UI control inherits from NSObject. NSObject does the memory management. UI control handles the targeting. And then UI button and UI text field are subclasses of UI control, and each has their own behavior, their own look, etc. One thing to note here is that NSObject's a fairly useless class on its own. And same with UI control. There's still, you may find uses for these, but in general, what you do is you use these guys in your methods, in your classes. You don't tend to use these top ones. So they inherit from each other. Again, NSObject handles the memory management for these guys and all the way up the chain. Memory management, generic behaviors, specific behaviors. OK. So all of you should be familiar with object-oriented programming. I think that was a prerequisite for this course. If you have any questions about it, please drop us a line. Use Troy or Paul's office hours this week if you can to get up to speed. That's the first piece that you got to make sure you're up to speed on. Of course, there's all kinds of books on it, and this is a fantastic overview of Objective-C object-oriented structures. So if you have trouble with this, please take a look at that. Any questions so far on object-oriented programming? No. OK. So let's get into Objective-C. First, everybody's heard of Objective-C, obviously. How many people have heard of Cocoa? OK. Can somebody tell me the difference between Objective-C and Cocoa? Yeah. Kind of. So you said Cocoa is the UI framework that's written in Objective-C. That's partly true. But it's more than that, too. It includes classes that are not UI. So things we'll talk about in a little bit called the foundation classes are also part of Cocoa. Basically, Cocoa is Apple's implementation of objects in Objective-C. Objective-C is a language, and let's get into that first. So Objective-C is a very simple language, but it's a superset of C. It's C reformatted with some ability to do objects. You can even do C++. There's something called Objective-C++ where you can mix C++ style classes with Objective-C. You'll tend to find the Objective-C, the non-C++ stuff more often, more frequently. OK, so it's pretty simple, but there's a lot of new syntax. Most people, when they see it for the first time, they get freaked out because there's all kinds of there's these square braces everywhere. We'll distill some of that and make you more comfortable with it. There's only single inheritance. So there's C++ and Java allows multiple inheritance, which means they can have multiple parents and get different methods from each. Objective-C is very simple. It's a very linear progression. There's a lot of the complexities of the language have been removed just to make it simple. There's something called protocols that allow you to, and categories is another thing. These are different kinds of behaviors on classes. So a protocol allows you to define certain behaviors that must or optionally will be implemented in a class. So an example of that is if I have if I have a table view that needs to get data, it has a protocol that's called a UI table view delegate. And if you want to provide information to that table view, you have to implement these methods. So a protocol is basically a set of functions that you have to implement if you're going to be receiving messages from another object. It's dynamic runtime. So everything is looked up and dispatched at runtime, not in the compiler. And it's loosely typed if you'd like. And the loosely typed means, so you don't have to specify the type of an object when you create your methods. You can, there's a type called ID, which we'll talk about in a little bit, where basically you can create everything with ID that doesn't specify the type. You can pass anything around. And it gives you a lot of power when you do that. It also gives you a lot of rope to hang yourself, right? So you can do a lot of things with it. But there's pitfalls of that as well. So I'll show you the ups and downs of both in a minute. OK, so on top of C, some syntax additions. The anonymous object is the loosely typing that I'm describing. So ID type is an anonymous object. Class and selectors are two different language level constructs for defining class, for identifying classes and for identifying selectors. Selectors are basically the messages that you pass to objects, and we'll get into that as well. There's a syntax for defining classes. Of course, C is not object-oriented, so there's a syntax for defining that within C. And there's a syntax for message expressions, and we'll get into that. Message expressions are, again, the calls that you make, the function calls that you make to an object. And as I said, dynamic runtime. So everything's allocated out of the heap. Okay? Can anybody tell me what's a stack-based object in C++ versus a heap-based object? Tim? Say again?
Local variable.
Local variable. So in C++, you can say, inside of a function, you can say the class name without a star and name it, and then you get access to that in place. It doesn't actually, it uses, as soon as the function gets popped off the stack, so does the memory associated with that object. That does not exist in Objective-C. There's everything you allocate gets allocated on the heap. You manage that. It's fairly simple. Again, this is again an example of something that they removed just to make it a little simpler. So the message dispatch is all dynamic. So when you say NSOb, when I say, let's say NSstring append string. So when I say append string on a string, it looks up that function name in real time and then sends the message. So you don't actually get compile errors if you try to call something that doesn't exist on a class. What you get is an exception at runtime to say, hey, you tried to call something that doesn't exist, doesn't work. So that's the message dispatching. And introspection. So this is a very powerful thing. I tend to use this a lot. But you can ask a class what kind of object it is. So let's say I have, again, an NSstring. I can be processing a chunk of code, and I can say, is this an NSstring? Is kind of class NSstring? If it is, do this. Is it an NS number? If it is, do this, right? So you can do that kind of branching. Any questions about this stuff? I'm just giving you the crash course on Objective-C. You just learned a new language. We're about to look at the syntax. So if you have any questions, fundamentals. Okay. So, all right, object-oriented programming with Objective-C. OK, classes and instances. OK, bear with me. A class is an object. OK. When I define a class in a header, that's actually its own object. There's an object type called class. That was one of the additions to the language. You can call methods on the class name. So we'll look at that again in a bit. But it's an important point to remember. Classes and instances are both different kinds of objects. And then as we talked about before, the class is the blueprint for the instance. So when you allocate an instance of a class, you're actually allocating memory to represent the blueprint that you defined above. So here's a little illustration of that. So I define my class. It has different kinds of data types in it, different instance variables, and it has a bunch of different methods. As I allocate each one, it creates a different instance of each one representing that block of data, its own block of data, and each one has the ability to be called with a method. All right, classes and objects. So classes declare state and behavior. This is instance variables and methods. State is maintained by the instance variables. Every instance has its own storage. What else? And the instance variables are typically hidden. So you can't say, if you have an instance of a variable and of an object, you can't access those instance variables directly. You have to go through something called getter and setter methods. There's ways that make the getter and setter, creating the getter and setter methods very easy. But it's an important point that you actually cannot get to the memory within a class without an accessor for that memory. Okay, so again, a very good document on object-oriented programming, the philosophy of object-oriented programming from an Objective-C perspective. Take a look at that link, another very good document. Okay, so let's look at messaging syntax. So as you start to build your assignments, as you start to make your programs, you're going to be allocating objects. You're going to be calling methods on these objects. This is the how. So, all right, instances can respond to different instance methods. So here's a few examples of what you can do. So if I have an object, in this case, it's a person, right? So I can initialize the person. I can ask the person for its height, or his height, her height, and I can tell it to walk, right? These are different kinds of methods. And classes can respond to class methods. So if I have the person class, I can allocate it. I can create a new person, and we'll talk about memory management another time. And I can, call another method on it called shared person. So this is an example of classes and instances both being objects. You can call methods on both. Oh yeah, right. So this is an important distinction too. Is when you have a minus here, you're actually calling functions that are on the instance variable. So you need to have an instance of an object in order to call these functions. When you have a plus, you're calling methods on the class. So again, if person is the class, you put the plus there to say that that has to be called on person rather than on Johnny. All right, message syntax. So here's where the square braces start coming in. Receiver is your object, is your instance, or your object actually. But message is the function that you're calling. It's the string it's the message that you're passing for it to go perform some action. You put them in a square brace to basically indicate that that's not atomic, but it's an operation in itself. And you can actually nest these things. So you can say, receiver 1, call a message in place of receiver, and then you can call the message on that instance that gets returned. The next one is with an argument. So messages can take arguments. In Objective-C, we do this by appending the colon and then following it with the argument that you want to pass in, whether it's an object or an integer, different types. So, and those get defined in the class themselves. And then if you have multiple arguments that you want to pass in, you basically you keep appending a string and a colon. So in C, you're used to a function name followed by brackets, and within the brackets are the comma delimited arguments that you want to pass in. In Objective-C, they're separated by identifiers. So this is like, what's an example? So if I say, person, I have a method called walk, and then I can say the destination and how fast, and I can say another argument, right? So this would be the person object. I could say walk, colon, and then the store, how fast, colon, 5 miles per hour. This is important. This is a very important point. You're going to be seeing this a lot, and this is probably a lot different than what you've seen before. So, yeah.
So and or, that's some other
No, so that's a good question. This is actually one method. So, yeah, sorry. So the question was, is and arg a common string that you append in order to pass in a second argument? The answer is no. The answer is that this is custom to the method. So if I say, again, if I take that person, and I have this walk how fast, or walk speed, that walk colon speed colon is the method, and the arguments get inserted when you actually call it. So, and each one is unique. So if I could say a walk colon speed colon, and I can have a walk colon, I don't know, clothes colon, and that's the object representing the clothes that he has to wear. Does that make sense? Is that?
It does, but am I right in thinking that, in a sense, that's redundant information, that in a standard procedure call, you don't need to say what it, you just say what the parameters are. You don't have to sort of declare usage, right?
Yeah, that is something unique about Objective-C. That all parameters are named.
Except for the first one.
Well, the first one is sort of it's usually the name of the first parameter is incorporated into the first part of the selector.
Okay, thanks.
Any other questions about this? Yeah.
So does that mean that the order isn't important since you don't have to list an order anymore?
No, the order is very important. So the position is fixed. You're always, yes, you have this prefix, but if you actually change them around, that's a completely different method call.
Oh no, I mean the order of the argument. So in C, you know argument 1, argument 2, argument 3 are listed in order 1, 2, and 3. But since you're naming them now, can you?
No, the order is still very important. Yeah, you can't just swap them. This tends to be the name of the action followed by the name of the arguments. I'm generalizing here, but yeah, you can't swap these around and expect that to work. That's a different function. So, any other questions on this slide? So let's look at some examples. So the voter class, I have this person class, and I have an instance called voter. When I call cast ballot, that's one method call, so cast ballot. I can call age, which returns a value. I can call set age, which takes a value. I can call can legally vote, which in this case returns a Boolean, and then you can do something with it if you want. Each of these are different method names. And here's a case where there's two arguments. So in this case, I can say voter, register for state, the name of the state, or the ID of the state, followed by party, which is independent. And again, in this case, you can kind of read from left to right, and it kind of makes sense. Register for state, colon, party, colon, and there's the variables you pass in. If you were to swap it around, it would be a completely different call. And then down here, here's an example of nesting the calls. So I can say voter spouse, it returns the husband or wife, and then I can ask for its name, and then it'll give the name for that spouse. So this nesting actually gets used a fair bit. You don't want to overdo it. I've seen some pretty long function lines in my work, but it makes it pretty convenient when you're trying to do some simple stuff. Okay, so let's talk about just the vocabulary for these things. The entire thing from left bracket to right bracket, including the object, including the method name, and the argument is called the expression. After that, we've got the message, and in this case, you're passing, you're calling the method followed by the argument. This is the message you're sending to that receiver, and it dispatches accordingly. There's the selector, and the selector, again, it's checked at runtime. So each one of these would be unique, and I'll show you how to convert between strings and selectors a little bit later. And then the method is the actual code that represents that method. So it's your implementation, your subclass's implementation, your class's implementation, either one. Questions about this? Yeah?
I'm confused by the difference between the method and the selector.
Method and the selector. Okay, so in this case, so he said he's confused about the difference between a method and a selector. In this case, method is the name of the function that we're calling. But what a selector is basically the function pointer, right? So is that right?
It identifies what.
So okay, when you call a method on a class, it actually looks it up, and it looks for a selector, and then that selector gets looked up in a table and then dispatched to the object. So again, this is just terminology, but this piece here is generically called the selector, where in our case, method is just the name of the function. Yeah.
Is that like kind of inheritance, something like that, like, or is that so? The difference would be when you call a base class's method, the
Yep.
actual method call would be completely different from the selector.
Yeah. So the question is, if you have an implementation in a base class, is that
In two derived classes and the base class method call, then the actual method call would be one of the two base class, the derived class method, depending on.
so? Is the base? Yeah. I'm sorry. Well, okay. So let me rephrase this a little bit, which is that okay. Picture you've got this class, right? This blueprint. The blueprint has all these pointers inside of it that says, when I call this method, go look up the selector and execute a piece of code. So yeah. How else do I explain that? Yeah. Yes.
How do we just, if there are many possible methods that one could select based on the selector, so is there a way of disambiguation of which method is to be selected for this selector?
So the question is there a way of discerning which method is going to be selected by a selector? Yeah, that's right. You don't do it very often. You tend to, the way you use this in code is as you go through, you're making your function calls. The selector is all implemented under the hood for you. So this is really just the terminology of the different ways. Maybe once we start getting into code, it'll make a little more sense. Yeah.
Can you have different methods with the same name, but just different that take different arguments?
Totally. Oh, sorry, not with the same name. You actually have to. Each one has to be a separate. So again, the name is the whole thing, right? So if I go back to this slide here, and I say, where is it? Register for state and then party. So I could say register for state and then, representative. If I wanted to take different arguments, this whole thing, which is the name, that has to be unique if you're going to pass in different arguments. And each one has to be its own implementation. Now you can do things like, register for state and party, and register for state representative. They both go through the same code under the hood, but the interface to those functions have to be unique for each different configuration that you want. So, yeah.
What does the heading for one of those implementations look like for register for state?
Yeah, that's a good question. Do I have it? So the question is, what does the header look like that represents these objects? I believe I have some a little bit later, but to cover that, so again, in this case, we're calling a method on an instance. So it starts with the minus, right? Then we're followed by brackets, like regular brackets that identify the type that gets returned. In this case, it would be void. We don't return anything here. And then following that, we have this name, register for state, colon, followed by brackets for the type. So in this case, it would be NSString, and then we have the name of the variable. Then we have party, colon, and then NSString, and then the name of the variable. So essentially, yeah, you start with the minus if you're an instance method. You have the return type, and then you have the message after that. So we'll look at that. There's be plenty of opportunities to explore that. Okay. And now, so we talked about these different methods using the square brackets. But Objective-C2, which is what we're all going to be using, gives us a convenience method for accessing things without the brackets. If you're trying to, these getters and setters that I was describing earlier, you can actually get to the variables using dot syntax. You're not getting to the memory directly, but what the compiler does under the hood is it takes something like person.height, and it translates it. Let's look at that one. So person.height, it translates it into the brackets that you would normally write in the Objective-C 1.0 world, and then calls that method. And in the setHeight example, we would say person.height equals, and that translates it automatically into a method called setHeight. So if you want to overload either one of these, what you actually implement in your class is, in the first one, you would implement dash float height, and then you can do whatever you want in there, calculate it on the fly. And then in this case, you're actually implementing setHeight. So it would be dash bracket void setHeight colon float the variable name height. Right? So what this is essentially just a shorthand for trying to get to these variables quickly. Yeah.
So presumably the naming convention has to be followed. The name is appropriate.
That's right. So the naming convention. So the question is, does the naming convention have to be followed? Yes. Whenever you have getters and setters in Objective-C, the variable name that you're trying to get to, there's a way to overload this, but the variable name is the name itself, and to set it is always set followed by the variable name, and there's always a capital there for the first letter. So that's a standard, and you'll see that a lot of places. And if you do that, there's things you can do later that become very easy. Both on Leopard and on iPhone, you can you can ask for changes on values and stuff like that. So, any other questions on this stuff? Of course, you can nest these. So I say person.child.height basically says, in this case, person child, which returns the person's child, and it's essentially nested, the child height, and that calls. So in here you would get a dispatch to child on the person object. You get a dispatch to height on the returned object, and that's the nice, convenient shorthand. Actually, in this case, it's the setters. And sorry. All right. So Objective-C types. Let's look at this. So the ID. This is the anonymous type that I was describing earlier. If you want to loosely type your methods, you can use something called ID. Now, normally with objects, you're used to something with a star. So you would say, in Objective-C, there's something called NSString. You would say NSString star. But if you're loosely typing, you just use ID, no star, and that is it's a placeholder for an object. It's up to you in your implementation to do the right thing with that object, or else you could, you'd be operating on the wrong thing. But again, you have that flexibility. Then there's the statically typed object, which is kind of the standard name of the class followed by a star, and then your variable name to represent that object. There's no type checking. So again, Objective-C makes the assumption that you know what you're doing. It lets you do what you want, and then if you pass the wrong type of object into a function that's expecting something else, then it'll crash or it'll do whatever it does. And there is yeah, that's right. So for statically typed objects, there's compile time type checking. So if you have a method that takes an NSString and you try to pass an NS number, NS array, whatever, it'll tell you. It'll give you a warning. It'll still let you go, but it'll give you a warning. Yeah.
So how would it be different using ID versus, say, NSObject pointer?
OK. Well, actually, not a lot. Yeah, sorry. The question is, how is it different using ID instead of NSObject star? The answer is your implementation is the same. Again, it's just a convenience. So let's say you take NSObject. Actually, that's the same thing. So NSObject star and ID assumes the same thing. When you wanted to get a little stricter about your types, NS array instead of NSObject, then that's when you could do other things. But if you're, NSArray, for example, if this is an object that's basically array storage, I believe it takes, you can say add object and it's ID because it doesn't care what kind of object it is, it's just an object. Yeah.
So sort of an addendum to that is, let's say you've got an NSstring allocated. If you've got a pointer to that with an ID, then you can send a message like there's a method on NSstring which is uppercase string, and you could have an ID and it's actually pointing to a string, and you could call uppercase string and you won't get any warnings with the compiler. If it's typed as an NSObject star, and you call uppercase string on it, it's going to give you a warning and say, hey, you've explicitly typed this as NSObject. NSObject doesn't respond to the uppercase string method. So there are some subtleties there. Typically, when you're using loose typing, you'll use ID. If it's a method that doesn't exist anywhere, like you call foobar on this ID, and there's no foobar method defined anywhere in any of the code you're linking to, it'll give you a warning there as well.
Any other questions? Object types? Yeah.
Kind of like memory allocation occurs prior to you actually using the variable that's dynamically typed. You just like set aside a bunch of memory for it until you come across it.
No, you actually, everything has to be allocated. So the question is, what happens with the memory allocation if you, if you're dynamically typed? The answer is the dynamically typed stuff is a convenience. So if you actually have an object that you're passing into a dynamically typed method, you've already allocated that memory and you've passed it in, and you've had to allocate it with the type that you want. So I can't allocate ID because the compiler doesn't know what to do with that, but I can allocate NSstring and it knows how to represent the storage for that in the heap. So does that answer your question? Okay. Anybody else? No? Okay, so the next one is a pretty useful feature of Objective-C, which is the null object. And the null object is just that. It's represented by nil, and it's essentially just 0. In memory, it's stored as it's represented by 0. So you can do things like, if you try to allocate an object, or if you're checking to see if an object actually exists or is allocated, you can just see if, is it nil? You can say if not person, and if it's a nil object, then this would be true and it would return. So that's kind of a good way to check to see if anybody's passed something into a method. You can also do things like, let's see. So you can send a message to nil. This one's pretty useful. In Objective, in other languages, if you try to call a function on nil, you're going to crash, because what it does is it actually it looks at 0 in the computer's memory space, and then tries to look at an offset inside of that, and of course you're in some bad memory space, and then it blows up. But in Objective-C, you can send these messages to nil, and it has no effect. In fact, let's say you have a, let's take the case where it's person, you're calling the child method to see if it has a child, but person is nil. When you try to assign person-child to a variable, child, that's going to return nil as well. So what happens is you don't have to check for nil everywhere. You can write a lot of your code assuming that things will follow through properly. You're not going to crash. Now, there's pitfalls to that too, right? If you're expecting some value to come in not nil, and it's nil, and everything works fine, you don't crash, you don't see any exceptions, you're going to run into trouble. But it's a lot more useful than it is problematic. So, when you expect something, make sure you check for it, and otherwise you can trust that it does the right thing. All right, so the next one is the BOOL typedef. So Objective-C came out in like mid-'80s. There still wasn't a Boolean type inside of C. So Objective-C came up with their own. It's the all caps bool. And in Objective-C, we use yes and no to represent positive, true or false. So if you want to stick with convention, I would say use the yes and no. Initially, I held back on that because I was so used to true and false. And then I started using yes and no, and just became so much more legible. Is this true? Yes. Is it true? No. So that's a convention in Objective-C. It's available to you. Okay, selectors identify methods by name. So there's the cell type. This is another thing that's new to Objective-C, is the cell type. Now, cell is the it's similar to the function pointer. Again, it's the representation in the language of that function pointer. So when I want to, well, here, let's look at this example. So if I want to look up a certain selector by a method name, in this case, we say the method is setName : age : and I can get the selector, which can get translated this way, and then I can do things like I can say perform selector with object. So it allows me to be a little more dynamic with how I call things. And I have an example here for that. So here's an example of using a selector. So in this case, I want to see if, and this is the introspection I was talking about. I want to see if an object performs this selector. So first I'll say, I'll translate the selector into a cell. And then I will ask the object, do you respond to the selector? And if it does, then I go ahead and call it. If it doesn't, I just keep going. So again, this is another one of these things that allows the language to be dynamic. And you'll see the cell being used when we start using interface builder. So objects that perform actions, here's our our loosely typed object. So let's say you have an NS button or UI button, which you guys will use pretty soon. You set the target to your object, and then you set the action to the method that you actually want it to call. And that's custom to you. So, all right, working with classes. I got to boogie through these. So again, class introspection. You're allowed to. You can ask an object what kind it is. In this case, so there's a couple of different methods here. There's class. You can actually get the class object for an instance. You can get the class name for an object, and then you can even ask it, is kind of class. So in this case, I have an object. I want to know if it's a control. So I say is kind of class UI control class. This gets me the UI control class object, and then I ask it if this is of the same type. And if so, I do something. And then there's a variant of that, which is member of class. So is kind of class will return yes if it's true, if it's any of the subclasses of that type. Is member of class will only return true if it's actually that type. So if I have, let's take a UI control and a UI button. If I have a button and I say is kind of class UI control, in this case it'll be yes. If I say is member of class UI control, it's going to be no because it's a button. So you'll find that useful. All right, working with objects. Any questions so far about introspection or the kinds of questions you can ask of objects? No. So identity versus equality. Objects allow you to ask them if they are equal to others. The base class of NSObject basically, if you say, is this object equal to this object, it will return true only if the pointers to those objects is the same. But you can override that method in your subclasses. And what you can do is you can say is equal will actually check the data. So NSArray, you can have two different NSArrays. Two different allocations of NSArray, but it'll actually return true for is equal if all of the objects in that NSArray are equal. So even if you have two different instances. NSstring, you can say, there's actually a special case of NSstring, which we'll talk about later. But if I ask this string, are you equal to this string, if there are two different allocations of the same string, but the string is exactly the same, it'll return true. So that's convenient, too. And in your classes, you can, define what equality means and override that. And now description. So NSObjects, all NSObjects have something called a description, which allows you to print some information about it. By default, description returns the pointer, and the type of the object. So, in this case, we can say string with format. We have this %at. So %at in Objective-C basically allows you to get to the description of an object. You're probably used to %f and %d and these different printf types. In Objective-C, there's this additional %at, which allows you to put an object into a string, and it'll print out the description. Again, you can override the description and return whatever you want. And by default, it's going to give you the function pointer, or the object pointer, and the name of the class name. So yeah, this is very useful. In fact, I believe this is the basis of assignment 1B, which is that you're going to print out the description of different types of objects, or different objects that you have allocated. Yeah.
So for the assignment, that actually goes out to the console, since we're doing it as a console-based app.
Yeah.
But what's the equivalent on the iPhone?
Console. So there's,
Console for
yeah, what happens is in Xcode, actually we can look at that before the time's up if I get through. In Xcode, you've got this thing called the organizer, which is where you manage your devices. What you do is you click on your device, and then there's a few different tabs. One lets you see just basic information. One lets you see crash logs. One is a console. And then, I forget what the fourth one is. But then if you're running in the simulator, there's also, it's got its own console. It's a regular console. Yeah, use a system console. Also, Xcode, if you're running from Xcode, it's got its own console as well, so you see that stuff there. And I believe since everything's in the simulator this week, we're just going to be looking at the output in the Xcode console. All right, foundation classes. So this is where we start to differentiate Cocoa from Objective-C. Cocoa is the implementation. It has different kinds of different functionality. Foundation is this framework that provides all these different things. So there's different kinds of data storage. There's undo manager. There's I don't know if there's an undo on the phone. There's no file system on the phone either. But for the most part, Foundation is common between Leopard and the iPhone. So if you're developing for the Mac, you're developing for iPhone, you'll see a lot of these classes are common. Most of them fall into Foundation. So let's look at some of these. I'm going to try and whip through these. NSObject, again, is the root object. Everything derives from that. It handles memory management, introspection. It has basics for things like equality. You can ask any object for to perform a selector, and it's the NSObject implementation of that gets called and dispatched. We start getting into some subclasses. So NSstring, you're probably used to strings as being, a string of characters defined in two quotes. But there's, when Apple makes an application, they deploy it around the world. So to make sure that process is as easy as possible, we abstract our strings through something called NSstring. And localization is not the only reason to do this. There's all kinds of functions that NSstring provides that you're going to use. But you'll see you're going to use that instead of char star. And yeah, you're going to just, without a doubt, it's everywhere in the application, especially since the system uses it all over the place. If you ever look at your memory allocations, there's a program called Instruments that you run alongside to see your performance of your app. NSstring is just through the roof. And a lot of that's not even stuff you're allocating. It's just done under the hood. Okay, here's an example of a string. Now, just because you were using NSstrings instead of char stars doesn't mean it's any more difficult. The difference is this @ symbol. So if you preface a string, a normal C string with the @ symbol, you're actually creating an NSstring. It does it in place. It does it for you. And then you can do something like, NSstring, assign this string to this object. So that @ symbol is basically the bridge to that. Format strings. So here's a method on NSstring called string with format. Again, this looks a lot like the printf format. You use %f if you want float. You use %i if you want integer, or %d, sorry. You use %@ if you want the object's description. So in this case, we've assigned the NSstring Johnny to that variable, and then we've printed it out, and it actually prints out the string. Same sort of thing in logging. This one's the class. This one's the object. This one's the integer. And that's what it prints. Okay, you can also ask a string for to create a new string for you. So you've got string 1. You want it to be string 1 plus string 2. So you call the methods string by appending. Excuse me. String by deleting. There's a few examples. In this case, I start with hello, and I want to append world, and it string by appending string hello world. Yeah.
Well, how is memory managed here? Like if full string was a different string,
Yep.
Presumably string by appending string creates memory, right?
So
And gives out the pointer.
right. So the question is, how is memory managed with this? So you've got here's one instance of an NSstring object here. When you call this method, it returns a new instance of a string, and it actually creates a new one that now represents that. There's something called NSmutable string, which we'll get into in a sec. One thing to note is that a lot of these foundation objects, you can't change what's inside of them. That's why you have these string by appending string, is because when I've created this string object, I can't change it. But with something called an NSmutable string, I can. So yeah, it actually allocates a new string.
Do I have to freeze or who freezes?
Yeah, we'll talk about memory management on Wednesday. Yeah. So there's a bunch of convenience functions that make that easy. All right, I'm going to whip through these. I'm running out of time. So basically, is equal to string has prefixes. A nice, it's an easy one. There's int value, double value. There's float value. There's all kinds of different ways of getting numbers out of a string. Here's an example where if I call, if I called int value on hello, it's going to return 0. There's no integer in there. If I call int value on 449, it's going to return 449, the number, the integer. So that's convenience. Look, yeah.
What if it were hello 449?
That's a good question.
0 or I'm not sure.
Yeah, either returns. So the question is, if it was, you had a string that said hello space 449, what does int value return? The answer is I don't know. It's either going to return 0 or 449.
Check the docs.
Yeah, check the docs. Check the docs. Actually, for all of these, these are a few examples. Check the documentation. There's all kinds of different methods you can call in these things. So this, just really quick, I want to touch on NSmutable string. This is where you can actually change the contents of the object. So if I start with hi, and I want to append my favorite number is %d, and then followed with this format, it'll actually, without reallocating that object, you'll get your object will now say, hello, my favorite number is blah. So collections, let me whip through these. There's 3 different kinds of collections we're going to talk about: array, dictionary, and set. Okay, arrays are what you already know, which is you've got an ordered set of information. In an NS array, each one of those pieces is an object. An NS dictionary, in case you haven't come across these before, is a key value lookup. So I want to store this object I want to store this object by name, right? So I can say I have this piece of data, I want to store it as name. I have this piece of data, I want to store it as identifier. And then later, when I want to ask the dictionary for that data back, I say value for key name, value for key identifier, and it'll give me back the object that I stored in it. And each one of these also has a mutable equivalent. So there's NS array, there's NS mutable array, there's NS dictionary, there's NS mutable dictionary, there's NS set, there's NS mutable set. So I'll whip through these again really quick. These slides, again, will be posted online, so if you want to look at it in more detail. But the gist of it is, here's our array class. I can ask for the object at an index. I can do all kinds of things without actually modifying the array. And then there's a mutable version where I have an object and I want to remove all the objects. I have an array and I want to remove all the objects. I want to add an object. That's the mutable version. That's true for NS dictionary. So I can create a dictionary with a set of objects and keys. If it's not mutable, I cannot change that. And then there's NS mutable dictionary, where once I've created that dictionary, I can then call things like setObject for key, which will either change what's already stored for that key, or it'll store a new value at the key that you've asked it for. And NSSet, so NSSet is the unordered equivalent of a collection of data. So it's like NSArray, but you actually don't care about the order. You would use this in the kind of situation where you've got, is this set of objects equal to this set of objects? It doesn't matter what order they're in. You're just checking to see if they're the same. And then NS mutable set, which allows you to add objects, remove objects, intersect. So I can say, give me a set that includes all of these objects, and if they're duplicates, don't add them twice. OK, this is really cool. So you're used to C iteration this way, right? You say for I equals 0, I is less than count, I plus plus. And that's going to increment as many times as you hit until you hit count. There's a convenience in Objective-C2 that allows you to say, for person in array. And that actually iterates once for each of the objects in the array. Now, essentially, they're equivalent. This one is certainly more convenient, and it also gives you a little more just comfort. One thing you can, if you modified the array while you're trying to iterate over it, that's bad. If you did that here, you would never know, because you're just going through and you're asking, give me this object, but it's all changed from under use. So you can get to the end and it's all screwed up. But this one, at least it'll throw an exception so you know not to do that. Then there's NSNumber, which is basically a wrapper on integer and double and float and all these different things. If you're doing math, if you're doing number comparisons, you still use what you're normally used to. So in the last example was I equals 0. That's not an NS number, but if you want to store that number in an array, in a set, in a dictionary, you need to put it in an NS number object. And then there are other classes like NSData, NSDate, NSCalendarDate. There's a bunch of other stuff. NSData, there's a mutable equivalent, of course, which is basically a set of bytes. And that's it. So, all right, we're going to talk about memory management on Wednesday. The important thing for this week's assignment is that you should be using these class methods. So if it's got the plus, what you get back, you don't have to worry about allocating and deallocating. These are convenience methods that allow you to say, give me a string with format, and it'll return a memory managed string for you. So use these in your assignment on this week. Yeah. All right, and then of course, if you need more information on Objective-C, please look here. So sorry to rush through this last bit. Are there any questions about this? Any questions about what needs to be done for your assignment? No. If I can actually give me 1 sec, how much time do we have? Like a minute. Maybe I can skip it. You know what? We're fine. So yeah, go home. Good luck with your assignment. The thing to note is you're going to get the output of your assignment 1B. Look in the console. That's where it's going to be. And yeah, good luck. Send the email if you have questions.
For more, please visit us at stanford.edu.